Math 102, example 3.4.1. So here we would like to continue to find the zeros. Now in our last section, we were given one of the zeros to start with. This time, we aren't given any of them. So how do we go about finding at least one easy one? Because that's our method, is to take the first one that we have, and then we can do synthetic division to find the others. But I need one to start with. That's what this rational zeros theorem gives me. So I've got this thing P over Q, and that will be a zero of my polynomial. In that case, P is a factor of the constant term, and Q is a factor of the leading coefficient. So here I've got 6x cubed minus 5x squared minus 7x plus 4. So let's see if we can figure out what these P and Q things are. So again, P is a factor of the constant term. So here my constant term is 4. What are things that multiply to 4? Well, 1 and 4, and then 2 and 2. Now regardless of the sign of the number in the actual problem, when I list my possibilities, I am going to put a plus and a minus in front of it. So Q is a factor of the leading coefficient. So here my leading coefficient is 6. So things that multiply up to 6 are 1, 2, 3, and 6 itself. Now those are not necessarily the numbers I guess. The numbers that I'm going to guess are P over Q. So I'm going to put all of the P's over 1, all of the P's over 2, and you'll notice I am going to get some repeats as I write these, and so when I get a repeat I cross them out. Then I'm going to put all the P's over 3, and finally I'm going to put all the P's over 6, and I've got a few more repeats here. So this list is a list of my possible rational zeros. So let's look, for example, 3 is not in that list. So that means 3 cannot be a zero of that function. These are the only rational numbers that are going to work. Again, I'm throwing out the repeats. Now, that's still a fairly long list of numbers. I could just start guessing and hopefully get one. I am a bad guesser. So that's where our calculator is going to come in and help us. So I've graphed that polynomial, and let's see what it looks like. So here I'm looking for where that is crossing the x-axis. And it looks like it's crossing at -1, which is in my list of possibilities. Now to double check, let's pull up my tables. Let's hit second graph. At -1, the y-coordinate is 0. So my calculator is confirming for me that -1 is indeed a zero of this polynomial. So we're pretty confident -1 is going to work. So let's do synthetic division with it. 6 times -1 is -6, plus -5 is -11, times -1 is +11, plus -7 is 4, times -1 is -1, and I get the remainder of 0 that I expect to get. So at this point, we've reached where we were on our previous problem. I've got the 1, 0, which again I got using a combination of my list and my calculator picture. And to get my 2 remaining zeros, because here I will have 3 zeros, it's a cubic, let's use the quadratic, where here's my a, b, and c. So I've got -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And let's see what we get. So I get 11 plus or minus the square root of 121 minus, oops. Where's my darling thing? Minus 96 all over 12. So then underneath the radical, I'm going to get 25, and that is a perfect square. Let's continue this up here since I'm running out of room. So I'm going to write this as two expressions, 11 plus 5 over 12, and then 11 minus 5 over 12. So I get 16 over 12, which is 4/3. And then I get 6 over 12, which is 1/2. I would like to notice that 1/2 is in my list over here, and 4/3 is also in my list of possibilities. So we did list those. If we check my graphing calculator, now again, fractions are a little bit hard to see, but it looks like approximately 1/2, and then 4/3 is about 1.3. So even if we can't see them exactly, we can still look at that and say, okay, those sound approximately correct. Now for your final answer, do just make sure to list all three of the zeros. So -1, 1/2, and 4/3. 4/3, those are my three zeros, and that is my answer.